Today I'd like to talk to you about solar and battery usage. We'll talk firstly about batteries, different types of batteries and how to best get best life out of your batteries. We'll also talk about battery monitoring, how to monitor your system. We'll look at cabling and voltage drop in cabling in low voltage systems. We'll also look at solar technologies, some new products available, and simple design of small-scale solar systems. And then we'll finish with some new technologies in other areas, looking at some TVs and fans and lighting that's available. First of all, I'd like to start with batteries. Batteries can be very mysterious things. Just by looking at a battery, there's no way of knowing how full or flat it is. We need to do some further investigation. With batteries that we're using in our RVs, and by RVs I mean any type of recreational vehicle. Could be your motorhome, four-wheel drive, boat, caravan, camper trailer, from the small Toyota Hiace right through to the biggest Winnebago. With batteries for RVs, we should be using deep cycle batteries for our auxiliary battery bank or our house battery bank. Deep cycle batteries have thicker lead plates in them. These thicker lead plates are designed for continuous slow discharge and then recharging. And they will do this hundreds and hundreds of times. They are much different from the battery you would use to start your car. Cranking batteries or starting batteries have thin lead plates in them. They're designed to deliver a short spurt of high current to start an engine, and then they'll recharge very quickly. Because deep cycle batteries have much thicker lead plates in them, they are much more stubborn to charge. They take a lot more energy to get charged back up. And we'll talk about different types of charging shortly. When we're talking about deep cycle batteries, there's various different types. We've got our conventional deep cycle batteries, which are a flooded cell. These batteries have caps along the top of them, allow you to check your electrolyte and maintain your electrolyte levels in them with distilled or demineralised water, and also allow you to check your specific gravity. Grabbing a hydrometer that you can purchase from an auto store and checking the specific gravity inside the battery to determine its state of charge. More often than not now we're using what we call maintenance-free batteries. So these batteries don't have caps along the top of them, they don't allow you to check the electrolyte, but it means that they don't need that regular and constant attention. Maintenance-free battery is a word that I don't like as much. Every battery does need some maintenance. You know, you do need to check that battery every now and then to make sure the terminals are clean and tight, to make sure the battery's not bulging or overheating. You know, just to do a visual inspection on the battery every now and then is always a good thing. When we're talking sealed deep cycle batteries, we've got various different types, from your lead calcium batteries, your AGM batteries, your gel batteries, and mixes of those. Lead calcium batteries have got a flat black top on them. Lead calcium batteries generally have a little clear window in them that allow you to see whether the battery needs to be charged, whether it's fully charged, or whether it needs to be replaced. That little clear window in the top tells you that it's a lead calcium battery. Lead calcium are a maintenance-free deep cycle battery and can be, you know, stubborn to charge, like all deep cycle batteries. They require good quality charging regime. The batteries that we use most commonly are AGM batteries. They're a sealed battery. The reason we use AGM batteries is because they can be recharged a little bit faster. You can discharge them further without doing as much damage. All deep cycle batteries have a certain amount of life in them. That life is dependent on the way we cycle the batteries. Batteries are not an infinite power source. You will use them, you will replace them. When we talk about the life of a battery, we talk about its cycles. The deeper we discharge on each cycle, the less number of cycles we get. So an AGM battery that I might sell on the shelf, in its tech data sheet will say we can do a 70% depth of discharge on that battery, and we can do that 600 times. So if we discharge 70% each day, we'll get 600 days as long as we're recharging it full each day. If we use a battery and we are using it from full to flat every day, that battery will last a week or two outside its warranty period. You know, manufacturers are very good at knowing what abuse their batteries can handle. They will design their battery and design their warranty period around the fact that if you run it full to flat and recharge it every day, it will last just outside 12 months. If your batteries are only lasting 12, 18 months, 2 years, there's something wrong with your system. They're either not being charged properly or you're over-discharging them when you're using them. A good life on a battery, a deep cycle battery or deep cycle battery bank, a good innings is 3 to 5 years. I definitely have customers out there that get much longer than that, but they are very good at how they use their batteries, and they've got a well-designed system. 3 to 5 years is a good innings for a battery. I get a phone call probably once a week where a customer will ring me and say, there's something wrong with my system. The lights aren't working, the batteries aren't charging properly, there's something wrong. I say, well, how old are your batteries? Oh, they're 4.5 years old. Generally, that tells me that it's not a problem with the system. The system used to work perfectly, the batteries have finally reached the end of their cycling life, and the customer is chasing their tail trying to find a problem that's not there. The batteries just need to be replaced. Batteries aren't failing prematurely, we say they are murdered, they are being over-discharged. When we spoke before about, a conventional battery being able to up to 70% depth of discharge each day and getting 600 cycles, if we then discharge only to 50% each day, we might get 1,000 cycles. We discharge only 40% of the capacity each day, we'll get 1,200 or 1,500 cycles. That's how we extend the life of our batteries. When we design or do a design for a solar system for a remote property in the bush, I'm putting in a battery bank that might be worth $8,000, $10,000, $12,000. Big, heavy battery bank. The design for that battery bank is with a daily depth of discharge of less than 20%. That way, we can ensure that battery bank is going to last 8 to 12 years. A $10,000 battery bank you don't want to be replacing every 2 or 3 years. So how you use your batteries each day will determine the number of times you can do that. So then we come into, well, how do I monitor that? How do I know how much I'm using out of my batteries? The easiest way to do that is via voltage. Looking at a voltmeter or getting out a multimeter that you might keep in your toolkit and checking the voltage in your battery. I'll give you some readings for batteries. I'm talking 12-volt systems. If you've got a 24-volt system for a motorhome or something, just double the voltages I'm giving it. A battery that is fully charged at rest should sit between 12.75 and 12.85 volts. By resting voltage, we mean it's got nothing charging it. So we're not driving, solar panel's not connected to it, we're not connected to 240-volt power. The battery has been sitting there and there's no load connected to it. Our fridge isn't running, our lights aren't running at the moment. 12.75 to 12.85 volts, fully charged battery at rest. With every 0.1 of a volt drop, roughly equates to 10% discharge. So if we went and checked our battery and it was at rest, we didn't have any charge sources connected to it, there was nothing running from the battery, and we read it at 12.5 volts, roughly say we've got 70% capacity left in that battery. 0.1 of a volt to 10% is not a true reading, but it is close enough if you want to just have a general idea of where you're at. So 12.75, 12.85 full, 11.7, 11.6 volt is dead flat. Now I get batteries brought into me all the time that they'll put on the counter and I'll measure it at 9 or 10 volts. They are beyond flat. That battery has had a resistive load. Most of the time a three-way fridge left on 12 volts, and the battery has been over-discharged. It is very hard to recover a battery that has been discharged that far. Some will come back if they're nice and new, but once a battery has been discharged down that low, it has had its life significantly reduced. When we're monitoring voltage, we might see voltage above 12.8 volts in our battery. To charge a battery up, we need to apply a voltage into it greater than what the battery is sitting at. So we've got a battery that's sitting at 12.2 volts, we need to charge it up, we apply a voltage into it above that. Generally, for most conventional batteries, we're charging 12-volt batteries at about 14.4 volts. We're charging at the voltage up here, it lifts the battery voltage to charge that battery up. And because we've got these stubborn deep cycle batteries there that need good quality charge, we need to have sophisticated charging sources that know how to charge your batteries. When we talk about charging deep cycle batteries, we generally talk about smart chargers or fully automatic chargers. These units just have 3 stages of charge in them. Some of the newer chargers might have more than that, but the main 3 stages of charge you're looking at is a bulk or a boost charge, an absorption charge, and a float charge. Bulk charge means that the charger will deliver the maximum amount of current into that battery until it reaches until it reaches a level that the charger determines is it's 80 or 90% full. So the bulk charge is delivering as much current as that charger can deliver or as much current as the battery will take. It will then step into its absorption stage. During the absorption stage, the voltage stays constant, so we're still charging at that 14.4 volts, and the current starts to back off. The amount of energy we're putting into that battery slowly drops back. That might happen for an hour or 2 or 3 hours, depending on the battery bank, depending on the charger. Once the charger then determines that the battery is full, it will step back into its maintenance or float stage. The current drops right back and the voltage will drop down as well. We drop down from 14.4 volts down to anywhere from 13.2 to 13.6 volts of a float charge. A well-maintained battery is a battery that's always on charge. So if your vehicle is being laid up in a shed or not being used and it's not out in the sun and you don't have solar panels connected to it, it needs to be connected to a good quality charger. Same thing, every week I get a customer ring me and say, we put the caravan in the backyard, we left it for 3 months and come back and nothing works. The battery will slowly discharge while it's sitting there if there is no charging source connected to it. You know, a good quality battery charger will maintain and keep that battery full and keep it in good nick. The other way to monitor our batteries rather than voltage, we might use voltage for a single battery, smaller system, not as much load, we're just running some lights on a TV or something like that. We might want a sophisticated battery monitor for a more expensive battery bank and a bigger system, somebody that's running a bit more load. We can get battery monitors incorporated into our solar controllers. So with our solar regulator that we're using to regulate our solar charge, we can buy bits and accessory kits for those solar controllers that will allow us to monitor our total usage and our total charge. We can also buy it as a standalone battery monitor. These units, can range from $300, $400, $500, $600. And what they do is they are a small computer that we program to our battery capacity. We tell the unit how much battery capacity we've got, we charge the batteries till they're full, and then we tell or calibrate the unit that the battery bank is now full.